This video provides an overview of Amazon EC2 Container Service, otherwise known as Amazon ECS. Amazon ECS is a highly scalable, high-performance container management service that supports Docker containers and allows you to easily run applications on a managed cluster of Amazon EC2 instances. You can use Amazon ECS to launch and stop container-enabled applications, query the complete state of your cluster, and access many familiar features like security groups, elastic load balancing, EBS volumes, and IAM roles. We'll go over some of the important concepts and then go through a sample application deployment using the Amazon ECS console. Let's first go through the core components of Amazon ECS. Container instances are Amazon EC2 instances that have been checked into a cluster. You own the instances and can SSH into them if you want. We use the same Docker you're used to through the remote API on the local socket. Our agent processes ECS commands and turns them into Docker commands. The agent is all open source on GitHub, and we'd love to see you involved. A cluster is a collection of resources, primarily ECS instances and containers running on those instances. A cluster spans multiple availability zones and is really just a collection of resources. For example, CPU and memory. It is dynamically scalable. You can start with one instance in your cluster and scale up to hundreds or thousands of instances. You can model the containers that comprise your application using task definitions that define the containers you want to run together. A task definition also lets you specify the container's CPU and memory, as well as Docker concepts like links to establish network channels between the containers, and volumes to persist or share data between containers. Task definitions are tracked by name and revision, just like source code. Our demo will use two containers, an Apache server and a BusyBox. The BusyBox writes an HTML file every second displaying the time of day to a shared volume. The Apache server will read and serve the file. This is a task definition file. You can specify resources like CPU, memory, ports, and volumes for each container. The essential flag specifies whether the task should fail if the container stops running. You can specify the Docker image to use for the container and any volumes to mount from other containers. You can also specify what commands to run when the container starts. A task is an instantiation of a task definition. You can have a task with just one container or up to 10 that work together on a single machine. For instance, Nginx in front of Node.js or Redis behind Rails. You can run as many tasks on a container instance as will fit. ECS has an API for scheduling long-running applications. You just reference a task definition and the number of tasks you want to run. ECS handles the deployment and integration with EOB. Let's use these concepts to start our application. We're going to use the wizard to guide us through this application deployment. Let's select Amazon ECS sample. We are first going to create a task definition. The sampled application we discussed earlier has two containers, an Apache server and a BusyBox. You can use the builder to edit the configuration of each container. For example, you can change the image, or memory, or CPU. You can also edit the task definition directly from the JSON file. Once everything is set to your desired configuration, click Next Step. Next, we're going to use the service scheduler to run our sample application. Let's run one task and also associate it with an ELB. Before we can run our application, we must launch container instances into our ECS cluster. We're going to launch 10 instances. Select T2 medium and a key pair. Click Manage IAM roles to grant your EC2 instances permissions to access the AWS resources it needs, and for the service scheduler to work with ELB to route traffic to your instances. Clicking on the button will open a new tab in the IAM role creation one-click wizard. Click Allow. Next, click Review and Launch. This screen allows us to review the configurations we selected in the previous steps. Let's click Launch Instance and Run Service. What ECS is doing now is using AWS CloudFormation to launch the requested resources. Once the resource provisioning completes, we can click View Service. Here, you'll see that we have one count of our task running. We can click the Events tab to see what the service scheduler is doing, like starting tasks or registering load balancers. Let's click on the load balancer associated with this application. We're going to grab the ELB DNS name and visit it in our browser. You can see that the application is up and running. Let's make some modifications to our application. Select a task definition view from the navigation menu on the left. Select our current task definition revision and create a new revision. We're going to edit the JSON file and change the background color of our HTML file and add a few exclamation marks. Finish by clicking Create. The new revision of our task definition is now ready. Let's go back to our application in the service view. Click the Update button. Select the new task definition file we just created and click Update Service. The update is now happening. First, ECS waits on the stop task until the connections are drained from ELB. Then it starts a new task. Once the new task passes the ELB health checks, you can see your updated application by visiting the ELB endpoint. Lastly, let's scale our application. Click on the Update button again. Let's change the number of tasks to 10 and click Update Service. The service scheduler will now scale your application to 10 tasks. Hit refresh, and you can see that we now have 10 tasks running. Thank you for watching this video. Log in to the Amazon EC2 Container Service Console at console.aws.amazon.com/ECS. For more information on Amazon ECS, visit aws.amazon.com/ECS.